So, this guy right here, we got to optimize. It says if f is this on this interval, f has an absolute minimum where? Okay, now as soon as you see the word absolute minimum, that means you're going to test the endpoints of our function, which are both of these. These are x values, by the way, x values. And we're going to test the critical values. What is a critical value? A critical value is where f prime equals 0. So we're going to test the critical values and we have to test the endpoints. So let's find f prime. So we can set it equal to 0 to find our critical values. Now f is 1/3 times x to the third minus x squared. Okay, so when I take the derivative, 3 times 1/3 is 1, and so I'm left with 1x squared minus 2x. So then I got to set this guy equal to 0. And when I do that, I factor out an x, and I get x minus 2, and I get two x values. I get x equals 0, and I get x equals positive 2. And both of these are in this interval. And so I have to test -2, I have to test 0, I have to test 2, and I have to test 3. Now there's a way to eliminate, possibly eliminate some of these numbers that you have to test. Like this says absolute minimum. So if this guy or this guy, those are my two critical values, if those are relative maximums or local maximums, then I don't have to test them. But I don't really want to eliminate them because that's going to take time. Let's just plug these numbers in to see which ones give us the smallest number. So when I plug in -2, it'll be -2 raised to the third power over 3 minus -2 raised to the second power. So I would get -2 times -2 times -2 is going to be -8. So -8 over 3 minus 4. Let's make that have a denominator of 3. So it would be -20 over 3, which is -6 2/3. Okay. Next, we plug in 0, a lot easier. Whoop. When I plug in 0, I get 0 because 0 divided by 3 is 0, and then minus 0 is 0. So 0 is definitely not our winner. Okay, he's not the least. And then we've tried 2. We got 8 over 3 minus 4. If we find common denominators again, that would be a 3, and this would be a 12. 8 minus 12 is going to be -4 over 3. That guy is not the winner either. This guy is still the reigning champ. But let's try the 3. If I plug in 3, I get 3 raised to the third power divided by 3 minus 3 squared. So this would be 3 squared minus 3 squared because, that 3 has a 1 and it would cancel out with that 3. It would become a 2. So you have 3 squared minus 3 squared, which equals 0. That guy's not the winner either. All right, so our winner is -2. -2 is where we're going to find the absolute minimum, and so that's our answer. Now let's do a graph really fast so that you guys can see what the heck is going on here. So we have x to the third divided by 3 minus x squared. So let's get rid of that. We have x to the third divided by 3 minus x squared. Okay, so let's just go boosh. Okay, so this is our function, and we have boundaries. We have -2, oops, not equals. There we go. There's a boundary. Let's make it dotted line. And then our other boundary is, what was it? It was -2 and 3. So let's put another boundary here, x equals 3. All right, we'll make this also be, come on, that and that. Okay, cool. So those are our boundaries. That's the area we care about. All right, we tested this point right here, this point right here, this point right here, and this point right here. Come on. Okay, so you see our y values that we found when we actually plug stuff in. So the -2 gives us the smallest y value, right? And then we got 0, x equals 0, that's this guy. And we got x equals 2. Those we got because they're critical values. That's where the function has a slope of 0. And the 0, 0 is actually a relative maximum. Okay, so we didn't really need to test the 0, but it wasn't like any skin off our back. Plugging in 0 is really easy. And then we have 2, which gave us -1 and 1/3. Is that what I got? -1 and 1/3? Oh, yeah, I did, because I got -4/3. That's the same thing. So this guy lost, and the last one, when I tested 3, 3 was on the x-axis, and so that one also equals 0. So that's how you find the absolute minimum.